Good morning. In the previous classes, we studied about electric field. Electric field of a point charge, we said, is 1 upon 4 pi epsilon naught into Q upon R square. Now, we are going to learn about electric flux. The concept of electric flux will lead us to Gauss law or Gauss theorem. Any one of them, either you call it as a Gauss law or Gauss theorem. Now, what is electric flux first of all? See, the electric field is there, which is a uniform electric field. I have drawn it as a parallel lines now. Now I place a surface. For example, this is the surface I have taken. Now I place this surface like this and I take the electric field like this, right? Now electric field lines are passing through the surface. Fine. The surface has been placed normal to the electric field. Understand very clearly. The electric field and the surface are normal. Okay, now the electric field lines are passing through this area. Okay, and now we bring a concept called area vector. Now, what is area vector? Area vector is a line drawn perpendicular to the surface. Surface is there, perpendicular to the surface. This is called electric area vector. Area vector. Okay, now electric field is passing through like this. And you can think area vector is like this. Both of them are in the same direction. So we define the electric flux phi. We call it as phi. That is equal to electric field multiplied by the area vector. Remember, the electric field is a vector quantity. Area is also a vector quantity. But this is going to be dot product or scalar product. So, what does it mean actually? Electric flux is equal to EA into cos theta, where cos theta is the component. Now, when will you get cos theta? See, the electric field is like this. Fine, that's good. But if I place the surface instead of normal, perpendicular, I place it at an angle like this. Fine. Now electric field is like this and the surface is like this and the surface vector which is going to be normal. So this is the area vector and this is the electric field and the angle between these two is theta. Okay. Once again I repeat it very carefully, you listen. Now the electric field is like this and the surface area vector is like this, fine, and the angle between the electric field and the area vector, this angle is theta. This theta is arbitrary, you can change it, fine, and let us keep this in mind actually, fine. So, if I say electric field is like this, that is E, and the area vector, the component of the area vector, this being normal, this is adjacent side, so it is cos theta. So A cos theta is the component. So this is going to be A cos theta. So what is the electric flux now? Electric flux phi is equal to E A cos theta. That is how you derive this equation like this. I hope you understand the concept of electric flux. So what is the unit of electric flux? See, electric field is Newton per Coulomb and area is meter square. So, Newton meter square upon Coulomb. This is the unit of electric flux. Now, from electric flux, we move on to Gauss law or Gauss theorem. Because the Gauss theorem is based on the concept of electric flux. Okay. Now, I said to you, electric field is equal to 1 upon 4 pi epsilon naught into the charge q upon r square. Where did we derive this equation from? We derived it from Coulomb's law. Okay, now Coulomb's law, when you take a group of charges, right, the surface of charges, then it will become very complex. So, Frederick Gauss made a very simple method that's called Gauss law. Let us see how that is going to be. Coulomb's law for force was 1 upon 4 pi epsilon naught into Q1, Q2 upon R square. Okay, now let us assume a charge. Let us assume a point charge. Fine. Point charge can have more charges, right? Let us say the charge is Q. Let it be a positive charge, right? Now we know there is a charge. Now you know that electric field direction is in all the direction. Fine? Okay? Let me draw electric field lines. And it being a positive charge, we draw the lines of force in outward direction. Okay, how am I going to connect the electric field with the flux? What is electric flux? The number of charges flowing through a perpendicular surface, a surface which is kept normal. Now, what can be a surface which can be symmetrical to the center of the charge is nothing but a sphere. Okay? Now, a sphere is a symmetrical surface. Electric field is passing through, you see this surface here, right? And surface area is there, so A, small amount, so dA I can call it. Fine? So, electric field is passing through E, through a small surface area, dA. If you take the total surface area as A, or some books use the term S also, because we are talking about only surface area. Okay, now let us see, the charge is there, electric field is passing through. Let me take an example of a ball. You see, this is a spherical ball, hollow sphere. Inside the center, imagine the charge is being placed, and the electric field lines are passing through in all the direction. All the direction is passing through. Now we can calculate what is the electric flux. So, the electric flux phi is equal to, why the electric flux is there? What is the cause of the electric flux? Is not this charge? So, charge divided by, there is a constant we used here, 1 upon 4 pi epsilon naught, where epsilon naught is permittivity in free space. Okay? So, divided by the constant epsilon naught. And this is called Gauss law or Gauss theorem. Very carefully let us see. Charge is there, and I am taking an identical surface, a symmetrical surface, which is going to be a sphere. So ultimately, the electric field is passing through. There is a small surface here. You can call this as ds also. That's better actually. And electric field is, and the surface is perpendicular to that. Now, generally, we put the statement as that phi is equal to charge upon epsilon. So what does it mean? The electric flux, what does the Gauss theorem say? It is the total charge passing through a given surface area, fine, divided by epsilon naught, which is a constant. If I put it in another form, in the calculus form, I can write the same formula as integral E ds. Okay, integral E is the electric field. Everywhere the electric field is passing through. ds is the small surface area. Fine. Over the total surface area in a closed surface, right? Total surface area is equal to Q upon epsilon naught. This is another way of expressing the same Gauss theorem. See, the the surface integral of the electric field over a given surface, closed surface, is equal to 1 upon epsilon naught times the charge. Okay, that is what the electric flux is about. So we can say another way, phi is equal to integral E ds over a closed surface, which is equal to Q upon epsilon naught. Okay, so this is called Gauss theorem or Gauss law. In the next class, we will study about the application and the proof of Gauss theorem.